For over 50 years, the distance record set by the Apollo 13 crew in April 1970 stood untouched. Human spaceflight remained tightly confined to low Earth orbit. That barrier broke at exactly 1856 UK time, when the Artemis II crew crossed the 248,655-mile mark, pushing further from Earth than anyone in history. Inside the Orion capsule, the astronauts took a brief moment to honor their predecessors and remember lost loved ones, officially proposing the names Integrity and Carol for two newly observed lunar craters. Reaching this depth of space served a strict physical purpose. The trajectory required to swing around the moon naturally placed them at this extreme distance. Entering the lunar sphere of influence, the moon's gravity immediately grabs the spacecraft and accelerates its path. The window for celebration closes instantly. The crew scrambles into position. They drastically darken the cabin to eliminate interior reflections and configure their cameras with 80 to 400 millimeter zoom lenses. The distance record marks the starting line for a highly choreographed and intensely pressurized run of scientific observation. This image captures the far side of the moon. It's a jagged, heavily pockmarked landscape of mountains and impact basins we never see from Earth. Gliding over this terrain, the astronauts execute their lunar targeting plan, a rigorous, pre-calculated checklist of specific geological features they must identify in real time. We already have fleets of robotic orbiters mapping the moon. Putting human lives at risk for observation requires a distinct scientific advantage. That advantage is the human eye and brain. Astronauts process three-dimensional depth and spot subtle color shifts, like brown or orange volcanic regolith, that robotic lenses routinely wash out in grayscale. Artemis II deploys 4 highly trained biological sensors into an environment previously mapped only by machines. This diagram illustrates albedo, the exact amount of light a surface reflects. By judging albedo in dark features like Grimaldi crater, the crew maps the lunar crust. Within these, they track concentric annular rings and deep gorges around massive impact basins. Gathering this data requires extreme physical coordination. 2 astronauts cram shoulder to shoulder at a tiny window, firing off photographs, while a third rapidly dictates geological descriptions over the radio to Houston. They battle blinding glare from the distant Earth, rotating positions every 30 minutes to avoid fatigue. Their eyes constantly struggle to adjust between the bright glow of their targeting tablets and the pitch-black void outside. By pushing through these exhausting conditions, the crew generates a rich, nuanced dataset that automated orbital algorithms fail to capture. This orbital map details what happens as Orion passes the lunar far side. The immense physical mass of the moon entirely blocks all radio waves, severing the capsule's line-of-sight connection to Earth's deep space network. For roughly 40 minutes, Mission Control receives 0 telemetry. The 4 astronauts fly in absolute isolation, completely cut off from the rest of humanity. When they finally emerge from the shadow, the signal reconnects, and they capture this definitive view, an Earthrise suspended over the barren lunar horizon. Capturing that image verifies that the orbital mathematics held perfectly, proving that humans can successfully navigate the deep physics of space. Down in Houston, the science teams immediately begin processing the massive influx of audio reports and high-resolution photographs downloaded from the capsule. These detailed visual accounts dictate exactly where future Artemis crews will set up permanent bases, while pinpointing essential water ice reserves trapped in the shadows of the lunar South Pole. Artemis II operates strictly as a scouting mission. By stretching the limits of human travel, these astronauts are assembling the exact blueprints required for our eventual launch to Mars.